Welcome back to all my dear friends. Part-21 classes by Rohit Umang, Part 21 class 10 electricity. Welcome to all of you. This is the video of electricity class 10 part 21. In the previous class, in the previous lecture, we will discuss uh, uh, about the combination of resistance and some numerical problem. And part 21, we will more discuss about the numericals which on the base on the combination of resistance. That means whenever the so many resistance are combined in the form of the series and as well as the in the parallel. So here is the first question. In this question, find the value of equivalent resistance across the any 2 point of the triangle. Okay, triangle here is the ABC. So we consider about the these 2 point. No, because in the question asks any find the equivalent resistance between the any 2 points. So we are consider about the B and C. Okay, so how we find the equivalent resistance? Look at the figure carefully. I have three resistance which are in among this the two are the represent in the parallel. Okay, sorry, and that the two are represent are the in the series. So here we write again in the other form, write B here and C here. So between the B and C we are the one resistance R, and also between B and C two also other resistance are arranged in the parallel. Okay, these are the these are the R and also R. Now here we call it this is the point A. Okay, so I hope so you are able to understand okay how we arrange again in this resistance. So we here look at the figure and see the these upper two resistors are in the series, and if you combine this resistor again we get the resistance, or in the series we combine the R and R, we simply add, then we get 2R, and R is also here. So so this is the final resistance of diagram. Okay, so here we can find the equivalent resistance by the help of the parallel combination. Okay, why? Because look at the figure, these are the look like a parallel. So in the parallel we can find the by the help of the 1 by Rp equal to 1 by R plus 1 by 2R. Okay, so after we finding 2R here, okay, and 2 plus 1. Okay, so here we get 3 divided 2R. So our final parallel equivalent resistance is what? Equivalent we can write here equivalent resistance is the 2R divided 3. Hope so you are able to understand how these types of figure which contains the resistance. So firstly we consider about the how it arrange. Okay, so in this question in this question I see that these two resistance are arranged in the series, and after combining this becomes 2R, and this is the one also arranged. So 2R and R look like in the parallel, so we can find the final equivalent resistance. So so move on the next question. So look in this figure, here is the I have a three resistance 6 ohm, 6 ohm, 6 ohm are arranged in this way. So find the value of I1 and I2. Okay, so where is the I1 and I2? Let's suppose it's also the voltage given that 20 volt, and after switch on current I is flow from this resistance, and so after coming at this point I divided into the two part, one is the I1 and other is the I2. So here is the value of I1 and I2 we can find. Okay, so how we can find? by the help of the after that I1 is the same for the this resistance 6 ohm and 6 ohm. Okay, but I2 is the different. So first we for the I1 we need a voltage and resistance. Okay, so look at the figure. Whenever talk about the these 2 points. Okay, these 2 points the voltage is same here 20 volt, and because in this path no any resistance are came, so we can only the higher potential are same here. Also in this point also we know that the lower potential have the 0 volt and higher potential have the 20 volt. Okay, so here we can also 0. So 0 and 20 these are the 6 ohm and 6 ohm, and after combining these are the arranged in the series, so we can get 12 volt. Okay, and after that 6 and 12 volt are arranged in the parallel, so we can consider that 20 volt and 0. So in this point the volt for the I1 is the 20 volt. Okay, why? I1 and I2 are both have the 20 volt, so here we write I1 equal to 20 divided by R. What about the R? R means the path of this circuit. Okay, 6 ohm and 6 ohm, that is the 12 ohm. Okay, so here is the answer is the what? 5 by 6 ampere. And also we can find the I2. I2 is this, so this is the 20 volt divided by 6. We can get only by 20 by 6 yani 10 by 3 ampere. Okay, so these are the value of I1 and I2. Okay, by this is the after see the video we understand that this is a so simple question, but how it how whenever we see these types of figure, so how we find the individual current for the 6 ohm and 6 ohm, and whenever these three are arranged in the some are arranged in the parallel and some are arranged in the series. Okay, so firstly we consider the voltage. Okay, so what is the voltage here? We can see the diagram and by the circuit analysis. Okay, find the voltage, and voltage for the point this and this. Okay, 20 volt, and also for the I1 and for the I2 both have the 20 volt because these are the arranged in the parallel. Okay, so hope so you are able to understand about this question. Now move on the second question. In this question we can see here only we can find current in the circuit. Okay, so how we can find this? For finding the current we need a first about the voltage and total resistance. Here is the voltage is the 20 volt, but don't have idea about the equivalent resistance. So first we find the equivalent resistance. For finding the equivalent resistance, how we consider about the resistor, which resistor are arranged in the parallel series. Okay, so here is the most important question. Look at the figure by the nodal analysis. What is the nodal analysis? This is the analysis of the point where is the potential difference is the 20 volt at 0. Okay, this point have the 20 volt and this point we can consider the 0 volt. Okay, and also this point is also the 0 volt. Why? Because no any resistance are available here. If you in the path of the current, okay, yeah, in the path of the wire, when you will go in if you know any other resistance are came, so we can consider the no any depreciate in the potential difference. So okay, so here we can also consider about the 20 volt. Here is the also consider about the 20 volt. Okay, so now move on the topic. Here is the also we can consider the 0, and here is the also consider the 0. Why we take a 0 0 and the 20 20? Because this is the higher potential and in this path no any resistance are came, so we can after these types of any question came in your exam, yeah, we can only focus on the if you have no any resistance in the path, so we can take the potential which have. Okay, so that's why we can take 20 and 20. Okay, and this side we can 0 0 0. Okay, now look at the figure. Now again we can rearrange in this resistance between the 20 volt and 0 volt. So here is the our we can consider also here is the battery, that is the 20 volt. Okay, and also 20 and 0. So after arranging, we also have here 20 volt, so we also write 20 volt. But after going toward this side, two resistance are came. Okay, so here it will be write 2R, and again these and these are in the parallel. We can take it in the parallel. Okay, so because these paths are both are the different things. Okay, so let me this point I don't have idea what is the potential difference. Let me suppose the x. Okay, so here we write the value, here they write the value x. Okay, so also 2R, and also this is the 2R, so we can write again the 2R after arranging. Okay, so these are the again 20 volt goes to the 2 ampere. Okay, so these are the also arranging the 2 ohm. Okay, and after arranging 2 ampere 2 ohm, we look at that diagram. We can determine the which resistance are in the parallel and which resistance are in the series. Okay, so one question maybe in your mind that how it arrange. Okay, why the only determining the point where is the potential difference 20 volt and 0 volt, we can simply take a resistance, and then we can take 2 R, and after that 2 ohm, and this is the 2 ohm. Okay, 2 ohm, 2 ohm and 2 ohm, sorry for that. Okay, 2 ohm, and after that these are the parallel. Okay, so here is the 0, and also we can take here 0, and we can take here 20 volt. Okay, why? Because in this path no any resistance are came, and also in this path no any resistance are came. Okay, so we can first we find the value of parallel combination. Here we look at the graph, and we can see that 2 and 2. Okay, after getting the value of RP. Okay, after finding the value of RP, look at the 1 by 2, 1 by 2, that is the 2 by 2, and that means 1. Okay, so RP is the 1, then 2 and 1 is the 3. Okay, then 3 entire resistance for that is the getting the 3 ohm, and 3 ohm and 2 ohm are arranged in the parallel. So final value of final value of R the speed, we can consider a final value of equivalent resistance is what? RP is equal to 1 by 3 plus 1 by 2, that is the 2 plus 3 by 6, and that means 5 by 6. So after the finding, we can hear the RP is equal to 6 by 5 ohm. Okay, so these are the value for the equivalent resistance for the entire circuit. So we can simply we can find the I is equal to V by R. V means what? V means 20 volt. Okay, and V by R. R means what? 6 by 5, that means the 5 divided 6, and we can see the 100 by 6 ohm, that ampere, sorry, 100 by 6 ampere. That is the entire value of current which are flow from this circuit. Okay, so I hope so you are not too much think about that. This is the tough question, complex question, but if you think carefully about the look at the figure and how it arranged, and how we, for the finding the how it arranged, we can consider about the voltage, how voltage are arranged in the circuit. Okay, so let's move on the next question. In this question we find the value of equivalent resistance between the point A and B. Okay, between the point A and B. So how we find the equivalent resistance in this question? First we think about whenever take a current I goes from the that way. Okay, so after reaching here, we can consider that these I are again go to this and again come to the that point. Okay, for after go to the this way. But in this type of question, whenever current goes from this point and again come to the that point, and that type of question we not consider about the that 2R 2R and 2R. Okay, so we can say this is the useless. Why we say this is a useless? Because the current I goes from this point and again come to that point, so we don't need to go in this path. We can only consider if I current are goes and then again we go from the that way. Okay, so this is the simply we can find the equivalent resistance by the eliminating the value 2R 2R 2R. This is the we consider the useless. So only equivalent resistance are that 2R plus 2R, that is the 4R. Okay, so final answer is the B. If you whenever I solve this types of question having the option bit, so we firstly pause the video and try to be do yourself. After that you will be get the answer. Okay, so that how I solve this. Okay, so move on the next question. In this question, reading of the emitter for the following circuit. Reading of emitter, where is the emitter? This is the emitter. Okay, so what is the value of emitter? We get here is the option 0.8 ohm, 0.8 ampere, 1 ampere, 0.4 ampere, 2 ampere. So finding for the emitter, that is we can consider first about the how current are flowing. Okay, so let me suppose this is the I current, and after reaching at that point divide into the two other path. Okay, so we can find that is the I1 here. Okay, and that is the I2 here. Okay, they don't need to be find the value of I2, we can find only the I1. Okay, so I1 we can find by the help of the total voltage divided by resistance. Okay, so here is the total voltage what, because we can consider that reaching at that point in this way no any resistance are came, so we can see here 2 voltage are here and also the 0 voltage are here. So okay, so we can see the figure, these are arranged like 1 ohm and 1 ohm, these are the in the series, but these series are arranged with 1.5 and 1 ohm with the parallel. So we can consider that the two voltage are same for the that. Okay, so we can firstly we find the voltage, we can firstly to find the not the voltage, we can find the resistance, how many equivalent resistance for that part. Okay, so we can find here voltage, here we write 2 voltage and R is the 1 and 1 and 2. So here is the answer is the 1 ampere. That is a simple way to find the total emitter reading for that circuit. Okay, so but we can if we that emitter is put and on that place, so how we find? By the help of the 1.5 plus 1, that is the 2.5, and voltage are the same. So hope so you are able to understand. That is the B is the correct answer. So move on the next question. That question had the ladder network shown. Okay, So current through the resistor 3 ohm is 0.25. Where is the 3 ohm? This is the 3 ohm. Okay. So then current is passed through the 3 ohm is the 0.25 ampere. Okay. The input voltage V is equal to, so here we find the voltage V. Okay, then voltage V, we need to if you go to find the voltage, we need a what we need a I and R. Okay, so I is what? I the current and R is the resistance. Okay, but we don't have any idea about the how much current it flow through the total amount of current, how much flow. But and also we can find by the help of the nodal analysis total resistance easily. But how we find the total current? Because total current find here is not mentioned, but here is the given that 0.25 ampere a current pass through the 3 ohm. So by this data we can find the total current, how much the total current found in the circuit. So firstly we find the current, so how much current are passed through that, and in such way we can also find the total resistance. Here is the look at that portion. Okay, this is the arrange in the series. Okay, because current are coming to the other and coming to the that way. So 0.25 ampere is same for the 1 and 2 ohm. Okay, so here we write for that portion. We can also write here again this figure is also written in that way. So that is the voltage. Okay, this is the 7 ohm and this is the 9 ohm. Okay, and after that this is the 8 ohm, this is the point C, this is the 5, and this is the 6. Okay, so here is the total value of resistance arranged with the C are the 3, 2, 5, 1, 6 with the parallel. Okay, so here we write 6 ohm. Okay, so can you find the current, how much current are flow through the 6 ohm? Obviously 3, 2 and 1 is the 6, and only can found is the 6 0.2 ohm, sorry 0.25 ampere. Okay, so but look at the figure. In this figure 6 ohm and 6 ohm are both are the same resistance and arranged in the parallel. So we can take we can say 0.25 also flow through the that way. Okay, so final how much current are coming pass through the 5 ohm, that is the 0.25 and 0.25, that we can say that is the 0.5 ampere. Okay, so we again we can arrange the circuit. So need to find the total current, 7 here and 9 here. Okay, so 9 ohm and also 8 here, this is the 8 ohm, and this is the 5, this is the 5 ohm. Okay, so after getting 6 and 6 are the parallel, after combining we get the 3 ohm. Okay, 3 ohm. Okay, so look at the figure. The total current flow through the 0.5 ampere also from the 3 ohm. So after again we can combining we get the value of how much current are flow through the how much current are flow through the 8 ohm. Let us see. So here is the 8. Okay, and here is the 9. Okay, so look at the figure, 5 ohm and 3 ohm, that is the 8 ohm, sorry 8 ohm, yes 8 ohm, and in this 8 ohm the current is flow through the 0.5 ampere, and so again we can say that this 8 ohm also gets a current 0.5 ampere. So right now we can say that the value of current for the 7 ohm, we can take the value of what we can 0.5 plus 0.5, that is the value of 1 ampere. So here is the value of the total current flow through the circuit, but I don't have till now the idea of total resistance. Let me again we arrange. We get the value of 7 and 8 kitna, that means the value of 4 ohm. Okay, and we again we here is the 9 ohm, and we after combining arranging with the cell battery. So here is the final value of equivalent resistance is the 4 and 7, 11 or 9, that is the 20. Okay, so here is the 20 volt. Okay, so we can find the V is the what? V is the I divided by R. I means what? 1 divided by 20. So I hope so. V is equal to sorry. V is equal to IR, है ना? V the value of V is equal to, here so we write wrong way. So V is equal to IR. Okay, so I means 1 multiply R means 20. So here we get 20 volt. Okay, so in the beginning of this question, it's after seeing the diagram, look seeing the diagram look very tough for the finding the total voltage, but step by step, if you have doubt any, so again we watch the video. So after that we can get the idea how it how we find the total current. Okay, so total voltage here we find. So again be the correct answer. So I have lots of till now question here, up to the 3 question are left. So but now video are going to too long. So after now I will going to stop this session, and in further classes I rest 3 numericals I will discuss with you. So and also with the next topic is the Wheatstone bridge. Okay, this is the new concept for finding the total equivalent resistance. So please come in the next lecture, and hope so you all are enjoying my class. And if you like the video, so please like and subscribe, and share those to those people which have need to for that. So that is the all for the today's session. Thank you so much. Keep reading, keep doing. You are the future. Thank you so much.